time period of a conical pendulum. First of all of you should know it is not the example of the simple harmonic motion, but it is an example of the periodic motion, because this pendulum will move like this, like earth moves around the sun. So this is the thread of length L and this angle theta at any time, and we have to calculate the expression for the time period. First of all, we draw the BD. Here the weight will act, that is mg. In the string, tension will act, that is T. If that angle is theta, of course this angle will be theta. This is taken as T cos theta and this component is taken as T sin theta. So we will say in inertial frame we are discussing, in inertial frame in which there is no pseudo force. So in inertial frame we will say T cos theta is given by mg, and this T sin theta provides the necessary centripetal force, and if we say radius is given by suppose r, then it is given by mr omega square. So we say this is equation number 1, this is equation number 2. We divide the equation number 2 by 1. What we are getting? Sin theta upon cos theta equal to r omega square upon g. Now what is the value of the sin theta? Sin theta is known as a perpendicular upon hypotenuse. So sin theta is known as a perpendicular is r, hypotenuse is L, upon cos theta इक्वल टू आर ओमेगा स्क्वायर अपॉन जी. यहाँ से हम लोग देखेंगे आर से आर कैंसिल, ओमेगा स्क्वायर इज नोन एज जी अपॉन एल कॉस थीटा. सो ओमेगा विल बी गिवन बाय रूट जी अपॉन एल कॉस थीटा. नाउ वी गेट द टाइम पीरियड टी इक्वल टू 2 पाई बाय ओमेगा. पुट द वैल्यू टू ओमेगा, फाइनल आंसर इज 2 पाई रूट एल कॉस थीटा अपॉन जी. So final answer of this problem will be 2 pi root L cos theta upon G.